Dear students and my dear learners, welcome to the video for Engineering Thermodynamics. This is a course for third semester, second year Mechanical Engineering from the syllabus of Anna University, Chennai. I am Dr.SUJA, Assistant Professor Mechanical Engineering from Thandai Periyar Government Institute of Technology. This is the unit for unit 1 for the engineering thermodynamics, and in the first unit we are going to study about the basic concept and first law of thermodynamics and its applications to closed and open systems for steady and unsteady flow processes. The course outcomes and learning objectives for unit 1, that is fundamentals, is the overall outcome from this unit 1 is to formulate the first law of thermodynamics for open and closed systems, for which the objectives are to define the fundamental concepts of systems, properties, process, states, and etc. And we have to learn about the difference and the definition for open, closed, and steady and unsteady flow processes, system, properties, boundaries, etc. And also we have to explore in detail for zeroth law and first law of thermodynamics and the application of this first law to various steady flow devices, because most of the engineering devices are coming under the utilization of thermodynamics laws. So we have to develop the energy equations for simple thermal machineries. Before going to the course or the course content, we will let us recall about what is engineering and what is thermodynamics separately. Already I have given a very tiny video for the introduction about engineering thermodynamics, and now I am detailing engineering. Engineering is a branch of physics combined with the mathematical models to find out the effect of the variables on the physical systems. Okay. Here also in engineering thermodynamics, this is also a branch of science deals with analysis of effect of temperature, pressure and volumes on physical systems. That physical systems is made up of substances, and we are approaching or analyzing in a macroscopic scale, and the collective motion of all their properties and their changes are being written in the mathematical models. Thermodynamics. So thermal means, you are aware that it is heat, and dynamics means movement, which is nothing but a power. Heat is also a type of energy, and power is the same, another one more form of energy, which we can directly say that power is useful to human beings or human community. So heat is going to be converted to power directly utilized for human community. Our purpose is to produce the power and by the supply of heat. It is the science of energy and its transfer from one form to another form. The best explanation can be given for this thermodynamics is by our digestive system of the human being. Okay. You all know that the temperature prevailing inside our body is between 36.5 to 37.5 degrees Celsius, or we can call it as 97.7 to 99.5 degree Fahrenheit. This heat, what this heat does in our body is, it is converting the food energy which we are taking into the human power or the work which is carried out by us. Food energy is converted to work energy by the supply of the internal organ heat and as well as other types of heat which is taken by us, like all types of hot beverages, hot food, etc. That heat content of the food and as well as our body heat is motivating or inducing the energy conversion from one form to another form. The same process is only being carried out in all the engineering thermodynamics applications. Okay. So, you know the importance of this particular temperature, the continuous this temperature range should be maintained by our body. If it is reduced or if it is above the limit, means you know the various effects and the impacts. So, maintenance of temperature in this particular range is also very important. How we are keeping us within this range, how we have to maintain this heat transfer. Okay, everything is same as whatever the things which we are going to study. Okay, and other this is the explanation which will give you the conversion of energies from one form to another form. If you don't take food, you cannot work. Okay, so food energy is converted to work energy. Regarding the application of this thermodynamics is on air conditioning system, aerodynamics, internal combustion engines, power plants, refrigeration systems, and so many domains. Here is a very simple example, shows that before the induction of the hot air, this air balloons would be in some other shape, you know very well, it would be in the ground level, and after it is being given, it is being supplied with the hot air with some pressure, then the effect of that heat under the pressure, temperature under the pressure of the air has changed the shape, volume and the state and the position of that hot air balloon, and which is now flying over the sky. Okay. So like this, heat, how it have a key role, okay, in the properties of the systems. Okay, in terms of engineering applications is only thermodynamics. Okay. So what are the various methods to analyze the systems is about macroscopic and microscopic approach. Okay. These two types of approaches, this is also called macroscopic is nothing but classical approach and microscopic is statistical approach. Here macroscopic, by the name itself you come to know this is little bit easier than the microscopic view. Okay. Because in the microscopic view, the matter constituting the system is considered the large number of discrete particles. You have to analyze each and every system. Number of molecules are very large in numbers. Okay, so each and every particle is being governed by the equations or the complicated mathematical models, statistics, etc. You need specialized tools to analyze in microscopic or statistical approach. But in the macroscopic or classical approach, attention is focused on a certain quantity of the matter, not in terms of each and every particles, without taking into account of events occurring at the molecular level. So here in macroscopic approach, it is sufficient to have the mathematical formulae, okay, which is used to analyze. Like we will take some of the properties, temperature, pressure, they are enough or sufficient to describe the systems. In the microscopic view, large number of variables are needed to describe the systems, because we have to make the models advanced and statistical models are required to analyze the system in detail. Okay, so we are going now taking the thermodynamic, the macroscopic or classical approach. Basic terms or terminologies used for in the course of this thermodynamics is our system, surrounding, boundary. Very important terms. System is a quantity of matter or a region in space preferred for analysis or study. Is nothing but here wherever you are concentrating, which place you are concentrating to for analysis. That place or the space is called system. Okay, if you are taking a hot water of 1 kg, water of 1 kg, and you are going to heat it, and what is going to be the effect of the heat on that water, means that 1 kg of water is only your system. Surroundings is you are going to keep on vessel for that hot water, no, that is called the surrounding. Surrounding means outside that vessel, it's called surrounding. Mass or region outside the system boundary, and the boundary means the outer surface which is separating the system from its surrounding. So here you can able to see from this figure is this is your system, and surrounding outside the system it is surrounding, and the boundary which is separating the system and the surrounding, and this is regarding the another one more example. Here you are taking a piston cylinder arrangement. This cover of the cylinder is inside, you are taking a gas of some particular mass. Okay, this is considered as a system, and here piston you have. So this boundary is considered as boundary, and outside this system cylinder arrangement it is surroundings. All in all the directions you have this surrounding except the that is the outside the boundary. Okay. Three types of systems: closed system, open system, and isolated system. System and its types. Now, control mass. So by the name itself we can able to see that we are controlling the mass in the closed system. That is nothing but you are differentiating the systems in terms of two types of energy transfers. One is energy transfer, another one is mass transfer. So here closed system, it is closed to any matters or mass. So no mass will be allowed into closed system. Energy transfer will takes place. Open system means it is open to both energy and as well as matter or mass. Most of the engineering systems are open systems, since you have to supply the substance, then only you can able to take the output. Isolated system is, it is a hypothetical or ideal system which is only imaginary, that neither energy nor mass can cross the boundary. The best example for isolated system is a universe, a separate thing, isolated thing. Okay. So we will concentrate more on this open system other than closed and isolated system. Here you can see the types of boundaries and various types of energy exchange, which was already explained. That the boundaries can be two types, whether it might be fixed or movable. That is, we can change the boundary or it can be fixed. And types of systems and energy exchange, that is exchange means energy exchange as well as mass exchange. And now this is the best example for open system, shows that a vessel along with the water, okay, is being supplied with the heat, okay, having heat transfer or energy transfer also takes place, and you can also pour some of the water and you can take out water from this vessel. So mass transfer also is possible and energy transfer is also taking place. Okay, so this is the example for open system. Another in the way, some other way we can also define homogeneous and heterogeneous systems. Means homogeneity, you can have this word, it is in single phase and have the uniform composition. Heterogeneity means it is more than one phase and not uniform in composition. Here you can see from the pictures why we are studying this homogeneous and heterogeneous system is nothing but when the heat is supplied or work is being supplied to the system, what will happen is purely depends on the homogeneity or heterogeneity of the system also. Okay, so this also plays a key role in the amount of or the quality of the work output. Okay, So this also should be considered. So you should know what is homogeneity and heterogeneity. Okay, that is the distribution of the components inside